Okay, welcome. Today we are examining a Q-Learning solution for the CartPole problem using Gymnasium. Let's break down how this artificial intelligence learns to balance the pole. So the first step is the setup environment. We start by importing essential libraries, Gymnasium for the environment, NumPy for numerical operation, and others for utilities. The CartPole version 1 environment is installed with human rendering for visualizations. The key parameters are set non-buckets define how we describe the continuous space 1, 1, 6, 12 buckets for position, velocity, angle, and angular velocity. Star bounds establish reasonable limits for each variable for make learning more efficient. Here I create a Q-table management. The system checks for an system Q-table file. If found, it loads it for demonstration. If not found, it initializes a new Q-table with zeros for training. Different parameters are set: exploration rate, learning rate, discontinuity factor, gamma, and training episodes. State state discretization. That function converts continuous observation into discrete buckets. Each state variable is normalized to 0, 1 range that mapped to its buckets. Yeah, this transforms the complex continuous problem into a management discrete one. The selection action uses the if-readed polytype with possibility text random action exploration. Otherwise, take the best known action for the Q-table exploration and then get explore rate decays exploration over time for balanced learning. Here in this loop or training episode, how do you say you prefer say for each episode environment reset and initial state is discretized. Learning and exploration rates are calculated for this episode. Each time each time set sorry action select and execute Q values update. Yeah, the Q action Q values update using Bellman equation. Q Q Q is SA plus equals alpha R plus G max to R S prime A prime minus Q S A. This progress we can ensure the progress every 15 episodes. How to use you can see in this training the table. I prefer to watch the episodes because the training is a bit large. Here, this is the demo visualization. After training, we run 5 demonstration episodes, all which shows optional action, no exploratory, and shows the learning pollution in data. So, give me a second. Here is the the CartPole. In the first demo, you can see is 45 seconds. The score the 75, the second the 173, and the 3, 4, 63, and the last is 53. So if we can again with another observation, you can see in the previous the values was different. So check again. Maybe the episode is better or is good. Is good. In this case, we can see the best episode was 4, um, and this is over. And I finally with mm, the quote today. The quote is, "If someone says I won't make it, I won't argue. I will just show them how it's done." This quote is something that I say every day because you need to understand you are not alone. You need to learn every day, improve every day. For example, in my case, I don't better in English, I don't better in programming, in this case Python or something, but I try to improve each day and try to show with this medium LinkedIn on GitHub. For example, here, this is my GitHub, my LinkedIn. So if you feel so good to share the points or found some project interesting, you can write me in LinkedIn or send me an email or write in the comments. So thank you so much. Um, remember, this exclamation is a good job for this. Sorry for that sound. My cat was a bit crazy. So thank you so much. See you the next time. Bye bye.